we're going to look at high quality graphs and also review some of the things we've been going over in this part of the chapter. Warm up. Find the coordinates of the vertex of the following function. So this is in standard form where we have ax squared plus bx plus c. And the vertex, if you recall, we can find the x value by doing opposite b over 2a. So you should be able to identify a, b, and c. A is the number next to the x squared, b is the number next to the x, and c is the number by itself. And so if we plug in, it'll be opposite 8 over 2 times 1, which is negative 4. That's the x value of the vertex. We still need the y value. So then we're going to plug into this function right here. So f of negative 4, we could say, would be negative 4 squared plus 8 times negative 4 plus 12. And so we can type that in exactly as we see it, which would be 16 minus 32 plus 12. I'll pop up my calculator and just type it in so we can see. And then that would be where our graph changes direction. All right, so again, we can just type it in exactly as we see it. We have our negative 4 squared plus 8 times negative 4 plus 12. All right, so that gives us negative 4. And so our vertex would be at the coordinate negative 4, negative 4. All right, our vertex is where it changes direction. How do we know if it's a max or min? Well, you take a look at the equation in standard form and you look at the a value. Here our a value is positive 1, so we know it's going to be right side up, like a smiley face. And here's that vertex. In this case, it's a minimum right there. Okay, so today we're going to look at some review and then look at drawing a high quality graph. So first, we're going to review vertex form to standard form. So given this right here, first of all, how does the function shift? So we look at the plus 8, and we know that that shifts 8 to the left. It's the one opposite of what you think, so left 8. And the minus 7 would be down. And so then the vertex would be negative 8, negative 7. So it says plot the vertex and sketch the quadratic. Be accurate of your vertex and the direction. So negative 8, 2, 3, 4, 5, 6, 7. Negative 7, 1, 2, 3, 4, 5, 6, 7. All right, so there it is. Here we know that it's going to be a right side up graph because 1/2 is positive. We know it will be wider than the original. So here's what our graph could look like with the vertex and not knowing the exact zeros. Is the vertex a maximum or a minimum? And here we know it's going to be a minimum because it's the lowest part of the graph. All right, let's convert our equation to standard form. And so you're going to do this with order of operations. We have 1/2 x plus 8 squared minus 7. So order of operations, or PEMDAS, it says we do parentheses first. All right, so parentheses will be x plus 8 times x plus 8. I like to stick it on the outside of the box and get the inside, or you could FOIL this. This would be x squared, 8x, 8x, and 64. So now in our second step, I'll write the 1/2. And then we're going to write what we had right here, x squared, combine like terms, so plus 16x, plus 64. And then we have that minus 7 hanging out at the end. And now we multiply, and then last we'll subtract the 7. So if we multiply this out, we will get 1/2 x squared plus 8x plus 32. And then again, you have that minus 7 hanging out at the end. So here's what that would look like. All right, last step, combine like terms. So we will combine these two right here. And we'll get 1/2 x squared plus 8x, and then 32 minus 7, put that in, and we'll get 25. So now we've changed it to standard form where we no longer have the parentheses. Okay, let's review factored form to standard form. So first we start with the x-intercepts, negative 3 and 1, the y-intercept as a coordinate, is right here, which would be, what are we going by? It looks like 0, 6. To find the a value, we're going to write the factored form. So we have y equals a times x plus 3. If you remember, the factors are the opposite of the zeros, x minus 1. And we're going to plug in this point right here and solve for a. So we have 6 equals a times 3 times negative 1. So we have negative 3, a equals 6, divide by negative 3. And we have a equals negative 2. And so to write the equation out, we put the negative 2 there, and we have x plus 3 times x minus 1. All right, so that's in factored form. Can we convert that to standard form? All right, so here we're multiplying 3 things. You can do any 2 first. So here I'm just going to distribute the 2 first, and I'll get negative 2x minus 6. And then we take that, and we're going to use a box and multiply it by the x minus 1. So we will get negative 2x squared. We will get negative 6x, we will get 2x, and we will get 6. And so if I write that out and combine like terms, it will be negative 2x squared minus 4x plus 6. And I should put y equals. And there is standard form. So again, you just distribute one first, the a value, and then you just multiply out your 2 binomials. All right, last one, standard form to factored form. So this one is, you have the inside of the box, you want to find the outside. This is box and circle. So we have 2x squared, negative 5x, and negative 12. So we want to know what multiplies to our first 2 numbers. That adds to our middle circle, negative 5x. All right, so what are some numbers that multiply to negative 24 that add to negative 5? That would be 8 and 3, and the 8 would have to be negative. So negative 8x, and we have 3x. We'll put our x's on the outside. One of them has to have a 2, and it will be much easier to put the 2 on the side here. 2x times negative 4 is negative 8. X times 3 is 3x. So there's factored form, x minus 4, 2x plus 3. And we should put the y equals. Let's find the zeros. So this 0 would be x equals 4. This 0, 2x plus 3 equals 0. Solve it. Subtract 3 from each side. 2x equals negative 3. Divide by 2. So x equals negative 3 halves, or 1.5. Those are the zeros. Oops, I forgot this is not maximized. Okay. So here's the new part. Can you draw a high-quality graph of this by hand? Okay, so make a high-quality graph of x minus 2, x plus 4 by hand. Follow these steps. First step, what are the zeros? Here the zeros are going to be 2 and negative 4. All right, so I'll graph those by hand. So here it is, 2 and negative 4. Oops. All right, since a quadratic graph is symmetrical, find the line of symmetry. All right, so we need to find the middle of these numbers right here. And it looks like here's the middle at negative 1. So where x equals negative 1. To find the vertex, it's along that line, but I'm going to plug in where x is negative 1 into factored form. So we have y equals negative 1 minus 2 times negative 1 plus 4. So all we did was plug in a negative 1 for the x values. This becomes a negative 3, and this becomes a 3, and so that gives us 9. So our vertex, when x is negative 1, the y value is 9. So negative 1, 9 is the vertex. Okay, and it says find another point on the graph. Let me double check this. Oh yeah, here, it should be negative 9. I was going to say this should be the other way. So this should be a negative 9. Sorry about that. Okay, so a negative 3 times 3 is negative 9, so it should go this way. Okay, so there is the vertex. And it should be right side up because our a value here is positive 1. We know it should be a smiley face graph, okay? It says find another point on the graph. An easy one is when x is 0. Plug that in when x is 0. All right, so plug in when x is 0. We have 0 minus 2. 0 plus 4, which is negative 2, times 4, which is negative 8. So 0, negative 8 is another point on the graph. So 0, I'll use a different color here. 0, negative 8 is right here. Using the line of symmetry, go the same direction across. So here's the other point. And we can now draw a smooth curve connecting our 5 points. Okay, let's try that one more time, the high quality graph. Okay, so we did the rest. Okay, let's do the next one. Use the same strategy as the first example to make the high quality graph of this by hand. All right, so first up, plot the zeros. And so one of them would be at 1. Negative 1, I should say, not 1. And the other one would be at 5. So 1, 2, 3, 4, 5, and negative 1. So those are the zeros. Let's find the line of symmetry, the middle. 1, 2. Okay, so here's the middle right here at x equals 2. Use that to find the vertex, so we're going to plug in to our function right here. F of 2 equals 0.5 times 2 minus 5 times 2 plus 1, and we get 0.5 times negative 3 times 3, which would be negative 4.5. And so the vertex will be at 2, negative 4.5. So let's graph that 2. All right, so there it is, our vertex. Let's plug in any other point value for x. So let's say x equals 0 and solve for the y value. So f of 0 will be 0.5 times 0 minus 5 times 0 plus 1. So this will be 0.5 times negative 5 times 1. Half of negative 5 is negative 2.5. And so we're going to plot the point 0, negative 2.5. 0, negative 2.5 is right there. Using our line of symmetry, we'll just go that same direction, or the other direction, and plot that point. And now we can connect these in a smooth curve. And we've made a high quality graph. All right, so that's what we're going to practice today. Some review, and you're going to be graphing some of these high quality graphs.